Okay, hello. So I will continue to talk about ontologies and semantics right now. So the agenda is including classifications, ontologies, how to choose between classification and ontologies. Okay. Oh, this one is no longer here. Sorry. So there's actually four. And then we start over here. So just now, we are actually talking about identifiers. So it's actually a string, okay? It's actually a string, or actually it's a string that is for one particular object only. But ontologies and classification system over here is trying to tell us, okay, how are you able to group similar objects into a set or groups of it? All right. So at this is where you actually learn classes or object classes. Okay. So information have limited value unless it can take its place for a general understanding of the world. So, for example, financial analysts learn that the price of a stock has suddenly dropped. It cannot help but wonder if the drop of a single stock reflect the condition of other stocks in the same industry. Okay. For example, this one is actually giving you some ideas where, for example, your tech stock is actually dropping. One particular tech stock is dropping. Will other tech stock which actually are going to drop as well? And if so, the analyst may try to ensure that the other industry are following a so-called downward trend. Is it only that particular industry having a downward trend, or is actually the whole stock market is having a so-called downward trend? Okay, and also the last one, okay, this actually the last one is talking about, he may wonder whether the downtrend represents a shift of the national or even global economies. This national, is actually just the local stock market, or is actually a nationwide, or sorry, not nationwide, it's a global stock market is having a drop or downward trend. Okay, so in that case, the analyst basically is asking a variation on a single question, right? How this one incident relate to that thing, to relate with another incident, or relate with something that's having connection over here. All right. So big data and resources are actually complex. So when data is actually simply stored in a database without any general principles of organization, it's impossible to discover the relationship among data objects. So identifiers that we actually have just now, if you don't have certain kind of rules and regulation rules actually for you to set the identifiers, if it's just a random numbers, there's no way for you to find out the relationship between different identifiers. Like for example, bank accounts. If for you, okay, you only understand it as just a set of random numbers. There's no way for you to know that what's the relationship between this account number A and account number B at all, right? But if you design a bank account number in such a way that it is actually having alphanumeric string, and the alphabets give you certain kind of meaning, maybe in terms of locations or which branch is it opening, that in that case you are able to link this identifier into one set of data where it's connected via geolocations. Okay, this is the thing what identifier can do. Okay, so to be useful, the information in the big data resource must be divided into classes of data. You are able to group them using the relationship of similarities that they have so that they are actually belongs into certain kind of groups. So in each data object within the class share a set of properties chosen to enhance our ability to relate one piece of data with another. So this one is actually a semantic frame, okay, if you learned before, and this is a source over here, so you can actually take a look. So lecture, and then you actually have a specialization of meeting, and then context, a large number of students, course is operating systems, level is difficult, and then you actually have, what else? If difficult, then pay attention. And lecturer, okay, and lecturer, you are able to link with another semantic frame where the lecturer is Prof. James, and then the tolerance is, and so on, the information over here. But you notice that this is one object, okay, one lecture, okay, it's not actually the object over here, but it's actually a class of lecture. And this class of lecture is having object of operating systems, okay, and having these kind of different properties and so on. And this lecturer is actually another class. This class is actually formed by you actually have a unique identifier or a unique instance, which is Prof. James. So all these are lecture and lecturer over here is actually classes, okay. Ontologies are the formal system that assign data objects to classes and relate the classes to other classes. You are trying to make connections, okay? Connections or relationships from one class to another class, okay? It's not really a unique object to another unique object. Once you actually group those unique objects, right, you are actually able to make sense between classes, and ontologies are able to do so, okay? So when the data with a big data resource is classified within the ontology, so data analyst can determine whether the observation of a single object will apply to other objects in the same class. Okay, and similarly, data analysts can begin to ask whether the observation hold true of a class object will relate to other class objects. So these are the things that we actually can do when you're doing your ontologies. How these things are actually connected, okay, are related. The ontologies help to determine how things relate to other things. How is it you actually have maybe a different kind of connections from one classes to another classes? Is it the connection is only one way or two ways or and so on? This is an example of ontology. Of course, it's not that clear at the moment, but when you refer to the slide, you can see they are actually different nodes over here, and these nodes actually go back to one particular object class and so on. So, classification, simplest of ontologies. So the human brain is constantly processing visual and other sensory information collected from the environment. And when we walk down the street, we see images of concrete and asphalt on millions of blade grasses, bird songs, and other persons. Every step, we convey the newer sensory input. The main question is over here is, how are we able to process it all? When you have so many noises, so many data flowing in, so many data flowing in, how are you able to process, collect first? You collect the data first, and then you process the data based on the sensory input that you actually have. You can see things, you can hear, you can taste, and so on. There's so many ways for you to collect the so-called sensory information from the environment. How are you able to process all these things? It's actually by sorting. You are trying to sort into a set of objects or a set of elements, and how are these objects and elements is actually communicate with you, okay, or interact with you, okay. So after you have sort it, okay, and usually when you're sorting it, you actually put them into a different set of class as well. For example, right now when I'm sitting over here, I can see, oh, there are some household items. Oh, okay, household items. Or there are some food over there, some drinks over there. I will not say, oh, there are some one piece of bread A, piece of bread B, piece of bread C over there. You know what I mean? We are trying to give them general classes, food. There are actually around maybe like 4 to 5 different foods that are put in my kitchen over there right now. Or on them, maybe there are many different kind of utensils. There are many different kind of things over here. But like even you can see it from my background, you see there are some books or some boxes over there. I will not say book 1, book 2, book 3, and the unique identifier for that particular book, but I'm using a word books to generally tell us what do we really have over there. Like for example, this one, grass. Okay, you will actually just tell, oh, there are actually grass over there. You won't tell, oh, there's grass A, grass B, grass C, and it's difficult for you to deduce what you have at the environment if you go very detailed and specific. Okay, that's the reason why over here we are talking about sorting your information into a set of objects, and eventually you group them into general classes. All right. And if we lack a cultural determined classification of object of our world, there's no way for us to remember what we see and no way to draw general inferences about anything. So this one is a bit philosophical, but eventually, if you're not able to classify, which is the simplest version of ontologies, you will not be able to make general inferences, but and of course this one is a bit philosophy again, you will not be human. Because we don't have the intelligence to understand the environment in the effective manner if we are not able to sort objects into classes and create relationships from us as an entity, as a human, and how we are able to interact with other objects or elements. So every culture has some particular ways to impose a uniform way of perceiving an environment. So for example, this one is actually trying to tell you hat. Denotes a universally recognized object where different types of materials, it can have size, weight, and shape. But eventually, we understand that you actually have certain kind of relationship where all hats are the item of clothing that fits over the head. Then you know that, okay, most of the time when there's actually a clothing and then you can actually wear it on top of your head, if there's a strong possibility, okay, it's actually a hat, right? Of course, they can have other things beside the hat itself, but with this particular type of materials, size, weight, and shape, plus this particular relationship, okay, all hands are items, clothing, and fit over the head. You'll be able to help you to tell that this collective information will be able to help you to tell that these are hats. Okay. So over here, it's trying to tell you here, all biological classification are built by relationship, but not by similarities. Okay. And then classification, simplest form of ontologies. Aristotle is one of the first experts in classification, and his great insight came when he correctly identified a dolphin as a mammal. Remember, a dolphin is actually a mammal based on our biological understanding, but of course, there's actually one main characteristic where large shore animals is distinguished by a gestational period in which developing an embryo is nourished by a placenta. So basically, this is what we actually do by mammals. And it's actually absence from other types of animals. That's the reason. And also dolphin is actually performing this. This is how Aristotle at this particular point are able to identify dolphin as a mammal. All right. And he also knows that dolphin has all these features, but fish did not. So that's the reason why he moved, okay, from a general perspective where most of people, because of dolphin is living in the water, that's who they think that dolphin is a fish. But in the end of the day, he correctly reasoned the dolphins as a type of mammal rather than a type of fish. Okay. But of course, this argument at the beginning is actually ridiculed by the contemporaries because they think that, I mean, it's actually quite obvious that a dolphin is actually a fish. Okay, but this is actually a crucial example to tell you that they are based on their classification on similarities. Similarities and relationships over here is different. The similarities refers over here is fish. It's actually supposed to be swims in water. So everything swims in water gonna be fish. Similarities. Relationship. Gestational period over here, which a set of animals are actually performing so. So in that case, you are linking with relationship. You might argue that, okay, fish, okay, swimming in water is a relationship. Similar, and then the gestational period over here is actually similarities. But over here, we are actually trying to explain there are different ways for you to classify or different ways for you to justify why you are classifying your objects or elements in this particular way. And Aristotle over here is actually trying to tell you in a very different point of view, but is actually an effective way, much effective way compared to using physical similarities or so-called biological not biological similarities. Okay, this one I try to correct it again. This one is actually based on biological classification, and biological classification is based on relationship rather than similarities. Because over here, similarities, we try to justify that similarity is what we can see right now from a physical point of view. But biologically, when you are doing the taxonomy on your I think I have a taxonomy table. Yeah, the taxonomy on the animal kingdom, you're supposed to use the biological relationship, okay, to differentiate all these classes, okay. But again, there's actually somehow at one point there's actually no right or wrong answer because this particular biological classification is actually more focusing on the biological aspects. Okay, of course you can also argue that swimming in water can be a biological aspect as well. So at the end of the day, they can still have two different sets of arguments. Okay, that's the reason why you are seeing that when Aristotle try to raise this point, is actually not accepted by the contemporaries, okay, or other researchers. But in the end of the day, in general, we believe that when you are creating these kind of systems, there will be definitely people or researchers that are accepting it, and also people that is actually so-called doesn't agree with it. But again, depending on the idea or the goal of your system or your research or your development, you will need to decide which one is actually the best for you. Okay? Do you want to classify your groups of unit or groups of objects using the similarity or relationships? Okay? Although people might say that, okay, these two are actually synonyms. Okay? So in general, over here, classification is a very simple form of ontology in which each class over here is limited to one parent class only. And to build a classification, the ontologist must do the following, including define class, assign class, position class with hierarchy, and test and validate all the above. And classification, the constructed classification becomes a hierarchy of data objects conforming to the set of principles, including the set of rules of polity that extend to every member of the class and to all of the subclasses of the classes, to the exclusion of the unrelated class. So all these are actually wording explanation. Okay, so this one you actually can go through yourself. Okay, you can actually do some reading on this part. Okay. And then yeah. Oh, there's still a lot. I'll pause a while, so later on you can skip a few minutes maybe, because I'm gonna check on the message on the Microsoft Teams, because today I'm actually a bit late on recording things. So maybe there will be a part 3. I'll continue back from here.